Hello, everyone. Welcome back from lunch. How's lunch? You still eating? Some of you still are. Hope you got a little bit more of energy now, so everyone fueled up. And we're going to go through a few things which is developing with Firebase. And this talk has been developed over a period of time because I'm running a software development agency and we're working with a lot of startups. And I'm also doing a lot of mentoring together with Google for Startups. And what I've accumulated over time is a number of questions that seems to continuously recur and come up. Some of them which have been surprising to me in terms of how people view the development of Firebase. And me personally, I joined as a Google developer expert since 2017. I've been developing with Firebase heavily since then. And sometimes it gets surprising to me when people don't find that leverage of speed and performance by developing with Firebase. So I started to think that maybe some people do it differently. Maybe we don't all see it in the same way. So in order to get the most out of Firebase, it is important to kind of, should have two mics. Thank you. It is important to adapt the shift of paradigm. Many of us coming from a traditional paradigm of back-end and front-end might recognize that illustration of a guy wrestling with another one. We have the front-end developers, we have the back-end developers, and we go back and forth. A lot of times we're spending on designing the database or designing the system before we go ahead and develop too much for it. And if you're going to go into Firebase, the shift of paradigm is a little bit more like that no back-end solution. You're the guy juggling everything, the full-stack developer who just takes care of both the back-end and the front-end. And that is really because we don't consider it to be a back-end. Doesn't mean we don't have a back-end. Obviously, there is resources running in the cloud. You have the cloud functions, you have the Firestore, the cloud storage, everything like that, effectively a back-end. But do not consider it as a backend in a way that you don't start from the backend and spend a lot of time building your infrastructure before you go to the front end. So today I'm going to give you about 3 takeaways. It's going to be a very short, a narrow talk. If the other talks that some have spread out a little bit widely, this is going to give 3 good takeaways that I see very often comes up with startups. So maybe a hands up. How many here are startup founders or CTO that are very much in control of the architecture and infrastructure on your team, technical? No? Oh, there we go. We got a few startups here today. So maybe this is something for you to take away with your team. Or if you are on a team, it can also be something that you can bring as a conversation together with your technical leads. Start modeling top-down. So when we work with Firebase, it's really a top-down approach. I like to work with it like this. So I start with a naive representation of all my views, represented as a JSON structure straight that I want to have later in Firestore. And whatever I want to have in my current screen, I make a document containing everything that is there. And I loop back and I adjust data if I need it, and I only start breaking out data into different collections or documents if I find that this is not really fulfilling my needs. And the rule of thumb should be 1 document represents 1 screen or 1 view. If it's difficult to get the data, you might be doing something wrong. That one is very important to know. Reading data should always be easy. And never make any joins. As a rule of thumb, never join collections. Make another collection containing that pre-joined data. So in order to illustrate this very easily, as a little bit of a warm-up exercise, we're going to just show what that looks like more concretely. And I'm going to use Flutter as an example. I hope you guys can read or follow with the code if you're not familiar with it. I like to work with Flutter because they are closely related to, they are working very closely with Firebase now and have been done for a time. And I find that if you get the Firebase mindset, you also very quickly fall in love with Flutter because there is a similar mindset of developing fast and getting productive. So in order to, if you just want to make a simple widget in Flutter where you're going to display, say, the name and an email of a contact, what I usually do is that we work very closely with the UI designers or the UX designer. We sit down and we build the UI together. And in this process, mocking up data, hard-coded straight into the widget. And this might say, I'm sorry if I'm really like explaining it as if to children. For some people go like, yeah, that's obvious. But for some people it's not. And I can see a lot of time people start from the back end and they start designing in the database and they're putting the data, how it's going to look like later. You're going to see why this makes sense. So you start very simply, hard-code the data, display it, get it on the screen, see what that looks like, pixel push it around a little bit until it looks nice. When you're happy, swap it to a stream. The same data that you had previously, wrap it with a stream, because now we're preparing ourselves for how it's going to look like when we get it from Firestore. And the purpose of doing this is because we want to see what happens with any flickerings. Streams very often emit nulls, or they have an intermediate state of asynchronicity where you don't have any data. So you want to make sure that your UI is also behaving nicely and don't start bouncing around in any weird way, that you get your spinners in place, etc. You can put in delays in order to see that more clearly. But this is also very good because still now you can sit down with your designers and you can work through the UI, how it's going to look and behave. So, all good. And here's the magic. Here's where you get the quick swap. And this is where the aha moment comes like, oh, where is that power of Firebase? Where is the no backend thing we're talking about? Now we just bump over to Firestore, that hard-coded data that you just had, create a hard-coded document in the collection, go back, swap it with this simple code. Boom. Now we are reading it straight from the cloud without spending any time at all writing any backends. We're not writing any API endpoints. We're not spending any time talking to backend developers what we want to accomplish, what is the shape of the data that we want to bring back to the client. Obviously, this is a simplified version of how development would go. But these are really the 3 steps in which, if you work this way, most of the time, you're going to see that you're speeding up the development speed of your app development. And the purpose of doing this is because you're not overthinking what kind of shape of data you want to have in your Firestore. Instead, you're just working with what works right now. And as long as this is not presenting any problem to us, this is probably some kind of documents we want to have in the Firestore. How we create those documents later, that's another question that you might want to work with in order to duplicate data or using cloud functions in order to compose them from other sources. But going this direction, you're going to have a very fast cycle of creating widgets and screens and new features in your app, and then work backwards from there to see how do we then get this data onto Firestore. Bit of a warm-up. So, another question I very often get into with people is that they are developing API endpoints and they are doing cloud functions, and they are making HTTP cloud functions that are functioning as an API towards the application. And we don't do that. We use Firestore to replace API endpoints. And also this is maybe, I don't know if that's obvious to everyone, but you can use that one, use Firestore as a gateway to replace any need for API endpoints. So a real-world example for one of the clients we're having is a fintech startup where we're making transactions from the app. And obviously, we need to push some kind of request from the client, get it authenticated and authorized in order to make that transaction, and then return back a result whether the transaction has been processed, finished, etc. How we would do this in any traditional type of application where you have a front end and a back end is you would make a post request to the back end and say, here's a transaction from my account to your account. I want to send you a bunch of money, and you're going to have to check whether that is allowed for me to do or not, I have sufficient funds or not. If you would build this into Flutter, you would make it into some kind of service. You would call make transactions. You would wait for that HTTP call to complete, and then you would need to check how it's going for your transaction. Now we have a need for one API endpoint to make the post. You need to make another API endpoint to make some sort of query to see what's the status, or even worse yet, you need to wait for this transaction to complete and return back a status or some kind of reference that I can continue querying. And I need to keep this into state management of my app to say, that reference ID that I had before, how is it going with that one? Or the worst scenario is wait for the transaction to complete, which can take time depending on what is the type of transaction. So what we proposed is instead, and how we solved it, was that we just using Firestore. And we used that as a common ground of communication between the backend and the front end. So you're taking the same paradigm as before, where you have a from, to, amount, and currency, but now you're passing in a status which always enforced by security rules need to be equal to requested. And also the UID of me as the transactor needs to always be written as the user I'm signed in with. What we do on the other side is that we're writing cloud functions that consume this. But now we're sharing this source of truth between the client and the backend, where the backend is running the transaction and I'm waiting to see how things are going. Writing the requested is always allowed, because it doesn't mean I'm allowed to do it, but now we have an audit log for everything a user tried to do, whether they tried to make a transaction from with insufficient funds or sending some other sort of transaction which is not allowed. We get an audit log that they can't modify. And in order to keep track of what's going on in its transaction collection or the history of things, I don't need to return any IDs anymore. I don't need for this to complete. The nice thing with Firestore is that it almost immediately, within a split second, finishes the transaction, and the network synchronization is actually running in the background. So what you get is a very snappy behavior from your UI, where writing a transaction completes almost immediately. And you can return back, make your UI responsive again. The user can keep interacting with things. And in the background, Firebase will start doing the network synchronization. The data is written into Firestore because rules are validated already on the client side. So they know you can write this transaction, but then writing the data into cloud will take a little bit more time. And then when the cloud function in turn starts making the transaction, we simply wait on the client side, waiting for the status to be processing, approved, rejected, etc. So you're shortening down the time of these very lengthy HTTP calls, which can require a bit of handshake, and you also need to wait for them to complete in order to know how things were going. Because writing to an HTTP endpoint does not necessarily mean it succeeded. It can be a network error, etc., that you need to take care of. So when we do this, we find that we get a much more responsive UI. We get a very high value of the audit log. For anything that is rejected, we can just keep it into the log of every transaction that has ever happened. And for you who do have a need to interact this with another system, maybe Firebase or Firestore is not the perfect place to keep financial transactions. Nothing is stopping you now from lifting this over to another system. Maybe you have a SQL database that you're also interacting with. But using Firestore as an intermediate replacement for an API endpoint works very well, because we're also retaining audits for everything that has happened. So Also, one of the things that comes up during startup mentoring is that they go, well, we don't feel that it's safe enough to write straight to Firestore. This is obviously a Firebase conference, so it's nothing new to you to write the rules. But in order to communicate this clearly with your technical lead or with your team or the CTO or whoever is the one that you need to convince about this, what I've found is that using the Firestore rules document is actually a good middle ground for us to communicate between people on different levels of technical knowledge. So in our case, when we work with clients, bringing the Firestore rules collection can also be a way for us to communicate how does this system work. Because if you write the rules in a nice way with the functions implemented, etc., you actually get a document that reads fairly well as English. And most people in the startup world, or at most levels in a startup, the founders or the CTOs will be sufficiently technical knowledgeable that they will understand logic, such as if, else, and this one and that one, or the logical comparisons between if I'm logged in and this is my account, then I'm allowed to read it. So what we get is a very nice technical document that reads, how does this system behave? So if we want to read it out, we can say, we're going to have a bunch of transactions, and I'm allowed to read them if I'm logged in as the person owning the document, and the document, the transaction which it was sent from is my account. Seems to make sense. At least we have now a communication between the product owner and me as a technical or development lead to say, this is what I think you want. And I can also say, and they're allowed to create it if they are logged in as the UID that they say they are. And you might very well notice here that you're only allowed to create, not update or delete. So we can have this communication between us on the development team and the product owner and make a very clear communication about expectations of how the system is supposed to be working. So for me, in this case, this has been a very successful way of presenting to stakeholders to say that Firebase will be a good solution for us, and also to convince them that they're in the right hands and that we will support them in this kind of manners for them to understand where things are going, how things are working. Because presenting them with the unit tests or anything like that might be very difficult to convince that this is as secure as they believe it is. And obviously, this screen might be also already well known to you. The rules playground should be your friend to play around with things, to see that all the things that you were assuming about the rules are working as they should. The rules playground is very, very, how do you call it, advanced in ways where you can test your rules and get a very strict breakdown into where things go wrong or right, and why are you having access to this document, or why are you not having access to this document. So for when you go into the rules section of Firestore, you can click the rules playground, and then you can choose whether you want to try to make a read, a create, or something like that, and then you just put in the document ID. You can fake your own authentication to put in any UID you want in order to test, will I be able to read or write this document if we were to create these rules? This is a very quick way to just validate what you want to do. Obviously, later is a lot of testing that needs to be done in terms of writing unit tests, and you can also do unit tests for rules, where you are testing them in order for you to not have to repeat this step over and over. But using this is a nice way to break down where you can see, we can confirm that I'm allowed to create if I'm logged in as the user requesting it, and is logged in as is defined by the passing UID is equal to the request authentication UID. And on the right hand, you will see a breakdown of every logical evaluation that was made by the rules framework to see they confirm that the data matched with the UID that I was logged in as. When you do the rules, make sure that your team do understand that there is simple aliases that are called read and write, where write is a shorthand for both create, update, and delete. That might not always be what you want. Very few times, in my experience, you want to just say something as crude as just write, because many times you don't want to accidentally delete documents. Creating and updating is very much fine. Very seldom it should be okay to just delete them from the client side. Reading we don't do as often, but you can actually also split down the reading into get list, where you're allowed to get a document or list them. So the summary of that is that you can replace almost any need for any API endpoint by just doing a write to a Firestore. You get an instant write completion, and the data sync is in the background. You get a snappier UI experience that completes much faster the round trip to complete that synchronous action. The good thing with that is that you also have offline access. If you have a need to make this request on a spotty network, you don't need to work with any waits or checks whether the Wi-Fi is on or off. This works very well when there's Li-Fi or spotty connections, that you have this offline data that it still write completes regardless of the network state, and the data sync will be in the background. Also, as Zhang also mentioned before, you have a very smart cache with partial updates. So the nice thing is when you read this data back, it's very effective. But there's also one thing that it works very well with Firestore is that it works as an internal message bus. Any write you're doing to Firestore with the Firestore SDK will first be propagated internally on the client. So you don't need to implement any state management or any message bus systems on your client. Instead, just do subscriptions to any collection. And when you write in one part of your system, the other part of your UI will also instantly update, because the first round trip will always be a local update, which propagates to other parts of your subscriptions. There's a network round trip that will come back to you again. So if you do a inspection on all of your subscriptions and do a little bit of bumping around in your UI, you might notice that you're getting data more than once. And if you look down into why that is happening, is because the first round trip is local, the second round trip goes to the cloud, and you get your data back down again, fresh from the cloud, confirm that it's still the same. But there are times when you can kind of need to have an API. There are times when you don't have much value at all in retaining any information in an audit log. And maybe it can be such as you want to trigger a process. Let's say you want to create an account, you want to trigger synchronization of some data, or you just want to start a backup. So what do? You don't want to use the Firestore. You really say you have a need for an API. It comes to the point, maybe it's just that you can't convince your shareholder that we can replace this with Firestore. They feel they have a traditional need for an API. Well, first of all, you should never call your own cloud functions using an HTTP API call from your own client app. There should never be a need for you to make an HTTP endpoint in the cloud function and then call that one from your own app. So if the call or the connection comes from your app, use callable cloud functions. They are in fact based on HTTPS API endpoints, but they come with the benefit of you being able to authenticate that this request was indeed coming from your app and nowhere else. When you do the HTTP API endpoints on the cloud functions, they are also callable from public, which means that you can't confirm whether this was internal or external access. Sometimes you have the need for both. Very often there is a need for integration with third-party systems. Maybe you need to be able to consume from the client's external system or from some Slack Slack push or something like that. But you want to share the logic. So what we do in that case is that we don't just implement the API endpoint and consume everything through there. Instead, we still do the callable cloud functions from internally in the app, and we implement another way to get into the app from externals, and we just go into the middle with the shared logic component. Very clear and easy when you paint it as boxes, but effectively it will be like this. So we will have one function that is generate report from an app. If we just want to have a function endpoint that triggers a process of generating some financial reports, generate report from app is going to be a callable cloud function. The benefit of this is that it's very easy for me to take out the UID of the caller. I can confirm whether this call was authenticated from inside my app, who is the person calling. All of that gets very easily accessed from inside the function, and it's very easy to validate. We could give a different type of access or treatment to the person calling this one, because it's very safe for us to say it's authenticated. We just need to check, is it also authorized? We create the report data and return the response. Downside of this would be we need to wait for that process. Maybe the generate report function takes a long time. We need to wait for it before we return back. From the API, we would do similarly. The difference would be, you see in this one, where we have an HTTPS on call. In the other one, we have an HTTPS on request, meaning this is an external API endpoint that can be called from anywhere. The downside of that is we need to work harder to check the authorization headers. We need to implement some sort of system that either unpacks the token or have some API keys or something like that. But it will be up to you to decide how do we authenticate the requests that are coming over the network from externals. So this is also the why we wouldn't do the same treatments from internal as external. But the same thing again, you generate a report, you have to wait for it and to complete, and then you return the data. But we can improve on this. How can we make this faster? What if we can just implement it as asynchronous results or in the times when we don't need to respond to anything at all? There is something called cloud tasks, where you can enqueue things to run at a later point in time, and they also have the benefit of configurations where you can say how many are able to run in parallel. So if you take the same procedure as we had before, we want to generate some reports, we just replace the middle where we are waiting for the response to finish, where we're just going to enqueue them and put them over to the cloud tasks. Enqueuing functions with cloud tasks will give you the benefit of you can schedule them to be triggered at a later point in time. That could be good, for example, if you want to run backups. You can at any time say run a backup, but the backup will not run until midnight or something. You can also limit the amount of executions that are run in parallel, which is very good if you have any limited, if there are anything such as a shared resource in the middle where you have a liquidity pool or something. You want to make sure that we don't have too many transactions at a time, because we want to make sure that we are just consuming from this shared resource at a certain rate limit. We can also do it in order to throttle the amount of requests that goes to any external APIs, such as if you have any integration with other systems, they might not be auto-scalable, because you need to remember that Cloud Functions is auto-scaling to almost an infinite amount of resources. So if you let Cloud Functions go wild, you can easily get up into thousands and thousands of parallel processes that start calling external APIs, and you might just DDoS the other system. In order to be nice to other people, you can rate this one and say, well, we have a very active app. But when we run things that start processing in the background, we want to make sure we don't kill our partners by throttling it to 100 requests per second or something like that. You can declare the number of retries. which means that it's also good if your external interface or you're interacting with any other systems fails to respond. You can also tell them how much you're going to back off a few seconds and try again, and how many times you want to do that before you call it quits. And it's also unifying a workflow or process like we did before. So to improve on the function that we did before, we do exactly the same thing. So generate the report from API. We come in, we need to fix something with authorization headers. We need to work quite hard on figuring out, is this request allowed or not? But instead of just creating the report as we had before, the generate report, we're replacing that with get functions, and we're asking the task queue to push on a task to the generate report functions, and then we just send back the status 200 immediately. What happens from the third-party integration is that they make the request, and instantaneously, if the request was approved, they get a 200 response within milliseconds. It's a very nice experience from the third-party integration, and we're doing the same thing from inside of our app. Because if now, before when we create the generated report, we had to wait for the report to be created and then wait for the JSON response to come back. In this time, we just go from inside the app, a callable cloud function, immediately call, we put it on the queue, and return back, all okay. If it was authorized and the user was allowed to perform the action, within a split of a second, the UI is going to get back into responsiveness, and now the process is going in the background. And this is almost the same as we did with the Firestore, but in this case, we're throwing away the audit log. We don't want to fill up any collections with scrap data that we're never looking at. The implementation of task queues is fairly simple. Like any other cloud function, you just declare them in the cloud functions, and you have a on-task dispatch configuration where you can say how many times do you want to retry this, and for every time you retry, how many seconds should you back off before trying again. And this is very good when you're integrating with other systems, because they might, if you, for example, you know how ChatGPT might not respond and it get unresponsive for some time, you don't want to be that nagging integration that just keeps pushing every second until it works. But you might want to implement something smarter, such as a backup strategy, where you say, okay, I guess I know this API will be likely overloaded at times. So if it is overloaded, let me just back off for a minute or something, and we try again. You can also set the rate limits, as we said before. You can have a max concurrency dispatches and set how many of these functions are allowed to run in parallel. And that means that your UI can be, your application can be very active with thousands and thousands of users trying to perform an action, but you know at no time will you have more than 10 of these functions running in parallel. Works very well when integrating with other systems, or when you're having shared resources on your own system that you want to be consuming at a slower pace. And within that function, you're just working the payload, and whenever you get the results back, simply write it back to a Firestore collection where the user can consume it and at their own pace whenever it's completed. So in order to illustrate that in a stupid example, you could have a simple button that's called Generate Report. And whenever you click Generate Report, it calls your callable to start the process. The button will come back into responsiveness immediately because that function completes instantaneously. And just immediately under there, you set a Firestore subscription to read all the reports where the owner is equal mine. So what happens here is that you don't need to wait for the report to be generated. And the good thing with Firestore subscriptions is that they assume no results is also good news. Because a subscription is not to fetch the data. The subscription is to say, let me know if and when there is something. So no results or not existing is a built-in behavior of just regular behavior for Firestore. There is no such thing as no response. It's just no data yet. So you can just simply subscribe to that. You're going to get a nice spinner on your list, or you just display it as an empty list. There are no reports. As soon as that report finish processing in your task queue, it's going to pop up in your list as if it was regular behavior. So the decision matrix you want to do, if you're going to be writing or interacting to create or start off processes in your system, start with Firestore. Work with Firestore as your first choice for anything you want to do. You have so many benefits from it. You get instant write completion, data sync in the background, offline support. It's a smart cache with partial updates, and this internal message bus. If that, for some reason, is not ticking off all the boxes, you feel, no, we need to go one step further towards something more of a traditional back-end, front-end, go towards callables. Now you go through the whole decision again. Is callables filling all your needs here? Because you're calling from inside of your own app, then of course you can always reuse the callables. The good thing is that you can start processes. You don't need to fill up your Firestore collection with documents you don't need. You're saving yourself money from those Firestore writes also. But the downside of it is that you don't get any offline support. This needs to work with spotty connections. You need to make sure that when the user is clicking the button, they are also connected to the internet. The last option you should go for from inside your app is to work with HTTPS APIs. But those ones are really good for when you're doing third-party integrations, or if you're doing anything such as server-side rendering, or etc. But an HTTPS endpoint in your Cloud Functions should be reserved for any need which is not from your own code. The last thing I want to leave you with is to integrate your Firebase development into the code review process. So if you're not already doing it, use app distribution for pull request reviews. Also use the hosting preview channels in order to make a faster pull request review. And you can let your pull request reviewer instantaneously check the status of your app rather than having them check out your branch, build the code, and test it locally on their machine. So I wanted to give you something you could copy paste, and there's going to be a link. So if you are, is someone not on GitHub here, by the way? Someone using Bitbucket or GitLab? Everyone here on Git, there is someone there who is not on. I hope this reads well for you. Otherwise, I think ChatGPT can help you rewrite it for GitLab if you have any other actions. But this is particularly written for GitHub and GitHub Actions. And this is a copy-paste that I wanted to share with you that we do internally in order to make our pull requests easier to review. So we're using preview channels. If you don't know about hosting preview channels, it is Firebase is offering, so you already know that there is Firebase hosting, but there's also something called Firebase hosting preview channels, which means you get a temporary URL that is short-lived that you can deploy your app to in Firebase accessed on the cloud. So it's up on the cloud and it works exactly like Firebase hosting, but it's a temporary URL that you can set the lifetime to, and it will expire and vanish after that lifetime ends. And it's also a difficult to guess URL, so it's not published publicly. And so unless you're distributing that link, nobody can easily guess where you have your preview channels or any like a temporary state of your app. So what we do is that on every pull request that you push to, we build the preview channel and we create it from your branch name. And the code there, if you go to bit.ly hosting preview, you can actually copy paste it because it's already pre-made to take the branch name and then just take away some things we don't, unnecessary naming conventions from that branch name. And then we push up a preview channel to Firebase hosting. And we also linking it back into the pull request so the reviewer can just click, test your app at its current state, and also review your code and more easily give you some feedback. So how that looks like in Firebase hosting is that you're going to get a number of these ones deployed under your Firebase hosting. You'll see a tab down there that says Preview Channels Beta. And using the code snippet below, we have a naming convention in our branch naming where we do issues / the GitHub issue number and then whatever slug behind you want to make it more memorable. The nice thing that comes out right now is that you can see that we get that exactly to be the hosting name also. We get 1561 migrate marketplace, blah, 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 .app.web, not something like that, .web.app. So it's very easy now to share this one around the team. They also get a quick reference to which branch is this hosting URL referring to, and it's going to expire and disappear in a few days. But to make it easier, we're also too lazy to share the link in any chats. So we decided to let's just post it back into the pull request directly. So in that link also, you get this pre-cooked way where we're just saying, hey, get all the preview channels that we do have. Fetch out the one that looks like my branch name here. And then we're making a comment into our own pull request from the GitHub action, and we're updating a comment, and we're putting a link to that one. So that one comes out very neatly like this. In your pull request, it says preview marketplace app for 3 days, and just click this link, and you can go and see the app at this pull request state. So the nice thing that happens now is that we want to work effectively, and we want to help each other build better code. So whenever I make a pull request, I want you to just not only look at my code, but I want you to click around in my app at my state, because I know you're too busy to build and check out and do all that stuff on your own machine. So I want to help you. Just click, view what I've done, and then get a green check mark, and you merge the code. So that is very short and intensely just a few things to take away that has been some things I've noticed, difference in behaviors we all develop. If you have any questions or if things went too fast, feel happy to reach out and ask more about it. I'm happy to share as much code or tips as I can. If anything was unclear to you, please do ask also. And that's all for me. Thank you so much.